Hi everyone, welcome back to our channel. Today we are going to solve problem number 34, that is for the circuit shown below. The switch was in position A at a time t equal to 0 minus. At t equal to 0, the switch was thrown to position B. Find the current I of t using Laplace transformation method. Okay, so whenever the switch was in this condition, so the switch was there at t equal to 0, which is nothing but at t equal to up to a time of infinity, the switch was in A position. When the switch is in A position, so we can write down the voltage across the inductor V equal to L di by dt. So that is equal to inductance value is 4 into d by I by dt. The time is how much? T equal to infinity. 4 divided by infinity, that is equal to 0. So the voltage across the inductor is 0. The voltage across the inductor is 0 means inductor is trying to act like an short circuit for the given DC supply. Okay. So now I am going to redraw the circuit. So for this DC supply is given, the switch is in position A only. So the switch was in only in position A only, and you can see here the behavior of the inductor. So when it is in position A, okay, so the current will flow across the resistor, and inductor will try to act like an short circuit. So automatically the current in this I of 0 minus the initial condition is equal to, so I want to find the current I of 0 minus. So I of 0 minus is equal to, what is the voltage we have been applied? 20. So I equal to V by R, that is equal to 20 volts minus 0 divided by R. R value is how much? As given in the problem, this is 20 ohms divided by 20 ohms. 2 ones are 2 twos are. Therefore, the initial current at t equal to infinity or t equal to 0 minus is 2 amperes. Now, this is all about position A. Now, at t equal to 0, it has been moved to position B. So in the position B, this is what the behavior of the network. Okay, this is in position B, and the inductor is available here. Okay, so the value of this resistor is 10 ohm, and this value is also 10 ohm, and here the value of this inductor is 4 Henry. Okay, so previously inductor was charged with the polarity is positive and negative. Now there is no voltage source, and this will act as an source, and the polarities are reversed as the red mark shown, and the current starts flowing as positive negative, and current starts flowing positive negative. So the formula for voltage across the inductor is equal to V equal to L di by dt. I am going to link all the three voltages by applying Kirchhoff's voltage law inside the loop. When you apply the Kirchhoff law inside the loop, the current is leaving. What is the leaving polarity of the voltage? Plus V. Okay, so it's nothing but V equal to L di by dt. Okay, so it is plus L is 4 into di by dt, and the current is leaving, or the leaving polarity of the voltage, minus I into 10. The current is leaving, the leaving polarity is minus I into 10 equal to 0. So this is nothing but the current I of t in time domain. So therefore all these are instantaneous quantity, small letters. So in more detail I am writing t. So this I can write as 4 into d I of t divided by dt is equal to I of t into 20. So I am going to apply the Laplace transform for this. As soon as you apply the Laplace transform, so Laplace of d by dt of I of t is equal to Laplace of I of s minus I of 0 minus is the Laplace transform. Okay, so here 4 into, so you are going to get s into I of s minus I of 0 minus, that is equal to I of s into 20. So here 4 into s into I of s. What was the current at t equal to 0 minus? This is nothing but at t equal to 0 minus, the switch was at position G for a time interval of t equal to infinity. Therefore the inductor was acting like a short circuit. Now after a t equal to 0 seconds, it has been pushed here. The initial current in the inductor was 2 amperes, that is equal to I of s into 20. So from here I can write down 4s I of s minus 8 is equal to I of s into 20. So this I can write down 4s into I of s minus I of s into 20 is equal to 8. From here, I am taking I of s as a common term, which is 4s minus 20 is equal to 8. So now I need to find out the value of I of s. I of s is equal to 8 divided by 4s minus 20. So I can write down it as 8 divided by 4. I am taking as an LCM, s minus 5. 4 5s are 20. 4 1s are 4 2s are. Therefore, I am going to get 2 divided by s minus 5. Okay. So in this equation, we need to find out the Laplace of this equation. Okay. So here this is I of s. I need to find out inverse Laplace transform to find out I of t. Already we know that the Laplace of 1 by s minus, L inverse of s minus a is equal to e to the power at. Okay, so then I can write down this 2 is a constant, 2 into, so this is in the form of s minus a, or generally we can write down Laplace of e to the power at is equal to 1 by s minus a. So if you apply inverse for this, then you'll get the same. Okay, therefore 2 into e to the power minus 5 is there, this will be plus 5t. So this is the current I of t. So the people get generally doubt here is why at current I equal to 0 minus we have been short circuited. This is the position of the switch at just before switching. So at t equal to 0 minus, it was at 0 minus for a time of t equal to infinity. In the position A, so it was there for t equal to infinity time. Therefore, the inductor will be charged and it will act like a short circuit. After t equal to 0 seconds, it was pushed to position B. Then we have to find the current. So that's why the inductor will try to act like a short circuit. This is all about the solving the problem. I repeat the problem here. So first we want to find out the current t equal to 0 minus, and the switch was there for a time of t equal to infinity. Then automatically you will get the initial current. Just use Laplace transform and substitute that initial current and start solving the problem. Then you can understand better. So this is how to find out the I of t by using a Laplace transformation. So thank you for watching. If you feel my content is useful, please like the video, please share with your friends, and if you have any doubts, let me know in the comment section. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulasiram. Thank you for watching. We'll meet in the another video. Yours Ram.